following that. And okay.
Okay, it's on. We're on. This is the once a week online get together. It's live. It's a blog for Santa Barbara, California's longtime telescope and astronomy club, ladies and gentlemen, the Santa Barbara Astronomical Unit. Heard and seen Mondays, 11 to noon for an hour. We call it the SBAU Astro Hour. I'm your host, Ron Heron. Proud to be vice president. I'll introduce you to the rest of the board and some very passionate members in a moment. Meantime, follow along on YouTube. Be ready to comment or ask questions down below. We'll get them on the air if we can, because I got to tell you, these are some of the brightest, most knowledgeable people I know. Come join our club. This Friday night, we got Skyman Bob Berman, Astronomy Magazine columnist, talking to us on the big screen inside Fleischman Auditorium up at the Museum of Natural History. We have a little 7 o'clock to 7:30 pre-cruise around the cosmos inside our planetarium at the Museum of Natural History. Find out all about us at sbau.org. Today, happy leap year to me. Happy whatever. We're going to explain it all. There's even leap seconds. You're not going to believe this.
Yeah.
Launched by SpaceX and something called the Intuitive Machines Project, I guess, plus NASA. A lunar lander known as Odysseus made it to the moon, landed on the South Pole. Oh, crap. It's exactly what the president sent to us. Oh, crap. Fell over. So all the pictures are going to be skewed sideways. This may sound like a 1950s Ed Wood sci-fi flick, but I got to tell you, they really are looking for Planet 9. Ed gave us Plan 9 from outer space back in the 50s. Remember that?
It's horrible, horrible.
Right. The moon's waning again. The moon's waning. It has this tendency to wane and wax, and it's going to give a stage. We're going to visit the Scorpion's tail to the Stinger stars. Got a new atlas of our Milky Way, a diagram. I'm going to touch on the starfish cluster in Auriga, comment on Ponsbrook Comet, and the Winter Albireo. Boy, what an hour we're going to have. Let's meet the gang. And I got to tell you, some of my favorite people. Jerry Wilson, married to Pat Forgy, is our beloved president, and it emanates all from his house to us. Chuck McPartland is our SBAU outreach coordinator. He's been running the parties, and I got to tell you, he's the best there is. And Pat McPartland, since Chuck gave up, I guess he gave up secretary duty to a guy named Andy Allen, and he's been doing a bang-up job. We got a full crew working now.
Yeah.
His wife, Pat, is our merchandise manager, and Patricia also holds down the new job of treasurer. There's our editor, SBAU's, the Astro Hour.
Morning.
What is it called? Astro News?
Astro News.
Astro News editor, Tom Whittemore. Doesn't miss his Westmont College duties at all for some reason. He's happy to be ensconced in this odors of bread baking from his
Actually, I'm baking right now.
Are you really? Hey,
I got to listen for the bell.
We'll all get toast afterwards. And he's married to Maureen. And here is Tim Crawford as somebody, Bruce. Yeah, hi there. Bruce joins us, but Tim Crawford's married to Karen, resident lens and telescope expert, does contribute a lot. We missed you last week, Bruce, but welcome back, Mr. Murdoch.
Thank you.
Spamfilter.com, and he's married to a wife named Bonnie. What we do every week, and I got to tell you, this is our last week of the third year. Next week, we start our fourth.
Wow.
It doesn't add up, though, because there's 52 weeks in a year. 3 weeks would be 150 plus 6. But this is number 158.
We need a leap week. There was a leap year.
Maybe that's what it is. You're right.
It's the 29th of February.
Next week will be number 159. This is 158, and we'll start all new. And this Friday night, I'm hoping for a big crowd for Skyman Bob Berman. He's a crazy cut up. Let me tell you, it's going to be great. His talk is called "Where is the Universe?" And I think it focuses on major discoveries that changed everything since 1998. What if he's going to talk about dark galaxies? Here's the silly stuff. These are forwarded from Jerry, the president. The Ratatouille are us. Remember them on Easter Island?
Oh, yeah, I like this. They're a big P&Z dispenser.
displaced Polynesians who made the giant shoulder heads turned out they're Pez. I had a Pez dispenser just like that. They really went well. A giant
You were
Pez.
back when I was in high school.
I
There's
know.
a guy who has a museum up by the KUIT up there on the hill,
Yeah.
Right?
and he's got a huge collection of Pez dispensers.
Uh-oh.
Can you still buy them? Can you still get them? Can you still buy Pez and the dispensers? Or
I
that?
have no idea.
I don't know.
You know,
Probably
just a couple of years ago, I saw him somewhere.
Okay, what do we got? This is the extraterrestrials herding Americans or Earthlings on board a free Wi-Fi. There you go. That'll get me
Free
on board.
Wi-Fi.
The book they came out with, if you watched Twilight Zone, was To Serve Humans,
Yeah.
Serve man.
to serve
Serve
man.
Man.
Right.
They also have an ATM aboard that ship, so let's all pile on, gang. These are funny. Oh, the two aliens are saying, of course, these days it's a lot easier to abduct these humans in large groups. There you are. All with their-
Free Wi-Fi.
Yep. Here's the stick figures hovering around the scientific laptop.
Oh, this is good.
Alpha Centauri is the subject that seems to be closer. No, our year is just a little bit longer by 1 day, and it'll be in this month. So she says to him, or no, he talks first. You know, it took until February, but I finally got all the distances updated. She says, I really wish we didn't have to do this. Proxima Centauri distance, 4,240.93. What the hell is that number? 42,000 light years? No.
4.24.
Oh, there's a point in there.
Yeah.
Okay. So the point is, does a light year go longer? The photon goes longer in a light year than it does in regular year, doesn't it?
A leap year.
A leap year. What did I call it? Yeah,
Yeah.
leaping. Astronomers hate leap years because they make light years 0.27% longer.
Yeah.
More than a quarter of a. Okay. And we have to even make up on that. You'll be talking about that this hour, Mr. President. And here's more stick figures. Arguing about the sun orbiting the Earth or the Earth orbiting the sun. Two people on both sides of that. And the man in the middle says, you know, when two people disagree, the truth is always somewhere in the middle. Maybe the Earth and the sun orbit a common center. Maybe we're a binary. It's annoying when people are right by accident. Well, that pretty much covers history, doesn't it? This one I liked because we all knew the moon landing was staged. However, we did go there. It was just part of Stanley Kubrick's movie. It was all filmed by him, cost an insane amount of money. My question would be, how come MGM didn't market little black plastic replicas of the monolith in toy stores? We could all wake up.
I don't look for that stuff. Maybe they did.
They probably did. I could, a big one, you know, at the foot of your bed, you'd wake up to a big tombstone with your name on it every day.
They should put it in the monkey exhibit at the zoo.
Yeah. Okay, here's some hapless aliens on a foreign planet, or maybe the moon, being wiped out during their picnic by our takeoff plane, our rocket ship going back to Earth.
No, a lunar lander coming in for a landing.
Oh, it's coming in. I thought it was taking off. Oh, okay, that's even funnier.
They wouldn't have been camped under a rocket that was getting ready to take off.
Yeah.
That's true. Yeah, right. When do we send Artemis 3? Is it 25 or 26?
What's that?
Artemis 3, the actual crew is going on their third.
Oh, that's a set for, I believe it's 26.
A couple of years away.
It's all sliding to the right.
Yeah, don't set your clock.
All right, this is pretty easy. Math bonds with poetry in a simple equation. Doesn't look like a limerick to you. Try this. A dozen, a gross, and a score, plus 3 times the square root of 4, divided by 7, plus 5 times 11 is 9 squared and not a bit more. Therefore, the answer's got to be 81, right? Poetry was not to be used like this. Let me tell you. Probably drives some people crazy. This is stuff you know. Tiny little sliver of the pie. My God, stuff you don't know is maybe an acceptable piece of the pizza pie, but not much. Yeah. And then the stuff you don't know that you don't know. Oh my God. Sounds like something Neil deGrasse Tyson would say, but it's probably true.
Very humbling.
What do you think we're going to be talking about dark galaxies? Are you boning up on that? Any of you? I'm hoping Berman talks about
There,
it on stage
there is
Friday.
supposed to be a dark galaxy, but I haven't researched it enough to put it in our.
So all the stars might be made of wimps.
I think that's a big step.
No matter.
You know, I have a question. Is the Berman talk, is that going to be on YouTube for the home use, or do we have to be in Fleischman?
No, it will go out. I believe it'll go out electronically so that you can watch it at home.
Okay.
You can be zooming it, but it will also be recorded to YouTube.
Yeah.
Okay.
It's delayed, is it not?
What?
If you're on, watch the Zoom Tube thing, it's delayed.
Yeah, we're going to have a test run tomorrow morning at 10, but I wish it was done live or at least inside Fleischman to see if we can get his sound. We have nothing but sound problems at that museum. Where are we here, Mr. President? Besides, there's the monolith on my screen.
Wait a minute. I hit the wrong button.
It appears out of Jupiter, I think.
There we go.
There's a big screaming, piercing thing in my ears. Okay, what do we got here? Did you send this out?
This is a Roman coin. Yeah, it was in the talking notes.
It's in his notes.
Is this about calendar? Light?
Yes.
Oh, okay.
Yeah, I didn't have a lot of good graphics for leap year, but anyway, happy leap year.
Yeah.
February 29, a friend of mine who I've known since kindergarten, but we sort of lost contact with each other. He was born on February 29, 1945. And he got a lot of razzing throughout school because
that wouldn't be a leap year.
What's that?
That wouldn't be a leap year.
44, excuse me.
Or, yeah.
Good point.
Yeah, has to be even.
What do they follow? They fall on certain odd or even years, just like presidential
Every
elections?
4 years.
Okay, might they be with presidential elections? Are they the same? That's
No.
4 years.
No.
This is a presidential election year, and this is a leap year.
It's a more complicated formula.
Yeah.
Well, I'm sure it is. Okay.
Not every 4 years is a leap year.
Except if it's divisible by
unleap
400.
because the leap year corrects too much. So the year is actually 365 days plus 1/4 day around the sun. And if we didn't correct and let it add up, we would eventually be celebrating, and not too far in the future, celebrating the 4th of July when it was snowing.
Just like the Southern Hemisphere.
Yeah.
Yeah.
Well, where do we get leap seconds? Where does that come in?
Well, we overcorrect. So every 4 years we add a day, like we're adding this month. But that would correct it if it was 365 1/4 days. But the quarter is a round off. It's really 0.2422 days, not 0.25 days. So when we correct a quarter day error, then we're overcorrecting. So periodically we have to make that up. And we make that up by every 400 years. Every year divisible by 400 years is not a leap year.
Now, why is that? I don't get it.
Because otherwise it's still not the same period. And so you'd gradually precess through the year.
So every so often we skip a leap year and becomes
Yeah.
eight in a row that are the normal 365 days.
Yeah, because adding a leap year adds too much. And eventually you have to take that cumulative error out.
Now I get it. Okay.
It's just like a Taylor series or something for getting a number. You add some, subtract some, add some, subtract some.
Now there is a leap second also.
Right.
And, there's an agency that keeps track of the speed at which the Earth rotates. And it's become very accurate now in the days of satellites. But it turns out that, let's see, where is that? I didn't highlight that. It's due to how fast the Earth is spinning, and the Earth is slowing down. in its spinning. So they have to they stop the atomic clocks for exactly 1 second at 11:59:59 p.m. on June 30th or December 31st to allow astronomical clocks to catch up. And that is known as a leap second.
And they don't always do it because it's not a uniform rate. It depends on weather. I mean, the winds around the Earth affect the rate at which we're rotating. The amount of water that's in reservoirs in the northern hemisphere especially affects it. So it's something that comes and goes.
Wow.
Yeah.
That's amazing.
Yeah.
That's really interesting.
It's called the International Earth Rotation and Reference Systems Service. It's a federal agency.
Do you suppose it's true for all the planets? They're all slowing down slowly?
Not necessarily.
No, it doesn't slow down. It changes. Sometimes it'll speed up a little bit. Sometimes it'll slow down a little bit. When we have aquifers that are full of water mass underground, and we pump it up into the system to use it on farms, that changes the distribution of mass on the Earth very slightly, and that affects our angular momentum.
Wow. Wow.
They're
like
changing
old
the
story of it.
rotational moment of inertia of the Earth.
Yeah.
Wow. Well, there's never friction involved.
Oh, yes, there is.
There is friction?
Yeah. There is friction from tidal waves moving along they all heat each other up a little.
It's friction on the Earth, though. It's not friction with our motion through space.
No,
right.
that's correct.
Okay. But weren't we
turning to power that, to overcome that friction comes from the moon, from its orbit, from the gravity that we mutually have.
Wow. Well, at one time, didn't the Earth spin as fast as Jupiter?
Yeah.
No, there's speculation about that, but I don't know that there's any evidence. The thing I read was that when we were hit by Theia, that defined Earth's rotation close to what it is now.
It was more the orbit of the moon that was much, much faster in the past.
Yeah, and it was a lot closer.
It was like 8 days or something like that.
Yeah.
And I've heard both sides. Some people say that the moon's spinning out and going away, and others say it's coming in.
No,
it's moving away by about an inch a year.
Right.
Oh, wow.
Because it's losing energy.
Someday, all the solar eclipses will be annular eclipses. The moon will be too small to block the sun. Appear too small.
Got it. Wow.
You also said something, Jerry, in the talking points about in I guess it's a huge amount of time that they won't have to adjust for the second.
Won't have to adjust for the leap year if you go far enough.
Yeah.
Think of it this way: there's no harmonic relationship between the Earth's orbital period and the Earth's rotational period.
Tidal friction of the Earth-Moon system slows Earth rotation very gradually and lengthens our day by about 1.4 milliseconds per century. That means that leap days like this month will not be necessary in about 4 million years.
Oh, geez. Boy, I hope I see it.
We'll compare notes. Write a note to yourself.
Every century we slow by a second.
No, by 1.4 milliseconds.
Oh, I thought
1,000th of a second.
Thousandth.
Oh, well, that's hardly okay. Good. Interesting. And what do the coins represent? That era, I guess?
Well, that's Caesar.
Yeah. This is from the astronomical photo of the day for February 29, 2020. They had this little blurb that said in 46 BC, Julius Caesar reformed the current calendar system. And it's been known as the Julian calendar. And he included the leap day every 4 years. And then in 1582, Pope Gregory XIII provided the further fine-tuning of the leap days, that leap days should not occur in years ending in 00 unless divisible by 400. And that was called the Gregorian calendar, and that's what we use today.
Aha.
You
So
know, I
that's-
took 2 years of Latin in high school, and the a person shown in your coins would be pronounced Julius Caesar.
I thought it was FDR on a dime on the left.
FDR didn't have breasts. Oh no, that's the wrong side. Yeah, okay.
Yeah, wrong side. There you go.
All right.
Okay. So a quick rundown of planets.
Line up.
Mercury and Mercury is too close to the sun. It's on conjunction 2 days from now. Venus is very bright, unmissable morning star, very early. I mean, very close to sunrise. Mars is magnitude 1.2 and maybe a bit challenging in the growing dawn. It's also there with Venus. Jupiter, an hour after sunset, Jupiter is up bright 50 degrees in the western sky. It's a nice object. It's in Aries, the ram. Saturn also reaches conjunction with the sun on Wednesday. And Uranus is in Aries, the ram also, along with Jupiter. And it's at the edge of naked eye visibility at about magnitude 5.8. That would take eyes better than mine to see it, especially here in town. So you need binoculars to see that. Neptune is too close to the sun in Pisces, sets about 7:24. It's up most of the day. Pluto, not technically a planet, is on the border between Capricornus and Sagittarius.
It's just a different kind of planet.
Yeah.
Okay, does conjunction mean like with Mercury, it's still on the other side of the sun, not on our side?
So it's too close to the sun, but that's superior and inferior conjunction. Which side?
Oh, something that you'll never see with a Saturn or a Uranus. They're always in the far side.
Just superior conjunctions for them.
Right. Someday you're going to talk about this later in the hour, Mr. President, but someday we're going to add Planet 9 to that list.
We're going to talk about Planet 9 right now.
Ooh.
It's not looking good for it.
But good old Pluto is still up there every time.
Mm-hmm.
It's a dwarf.
So this is the home of Pan-STARRS, which is on Haleakala Observatory. Pan-STARRS does data dumps. Pan-STARRS takes pictures of the whole sky every night. So you have day-to-day comparison of what moves. And it takes photos down to magnitude 24. It's a very sensitive camera. So they are looking for Professor Mike Brown of Caltech publishes periodic progress reports, because periodically the data from Pan-STARRS is released, and he reduces the data, he and his team, and so far they have not found it. They've covered about 78%, just under 80% of the sky where they think Planet 9 would be. So, and they have not found anything yet a good candidate for Planet 9. But the theoretical calculations for Planet 9 indicate that it is 6.6 times the mass of the Earth, and it's so that in the category of a super Earth. And these are common exoplanets in exoplanet systems, but we don't have one. So that adds to the urgency of finding it. Where is it? It should be about 500 AU out from the sun. Orbital semi-major axis is 500 AU. So that's a radius. So that it would make it the 5th largest planet in our solar system.
Can I ask two quick questions? Do we have a name for it if we ever find it? And wasn't Mike Brown the guy that demoted Pluto?
He was the one that found the data that they used to demote Pluto.
Oh, okay.
I don't recall whether he voted yay or nay.
Well, it's only fitting. It's only fitting he should find a new one to replace it then. If he
right.
We get 9 planets again.
So the second, in January 2019, the second Pan-STARRS data release, consisting of 1.6 petabytes of information, the largest volume of astronomical data ever released, was released. And they just finished analyzing that data, and there's no Planet X in it.
And they don't have a name.
Planet X or Planet 9, those are your choice of names right now.
Just amazing how our science of astronomy doesn't come up with big, long, convoluted names like they do in naming species and different parts of
Steph, I'm
chemistry.
glad they don't. We just have numbers.
That's right. Or simple terms like dark matter and black holes.
If they ever do find it, I like that Planet 9. I think that's kind of cool.
Well, you know, everybody be dragging out that Ed Wood movie.
So
Neil
this-
deGrasse Tyson had a lengthy diatribe on just what you're talking about. That, you know, if we see something that's a dark star, we call it dark star. You know, they don't put funny names out there.
Right.
Well,
The International Astronomical Union would be in charge of naming it if and when it's got an established orbit. So
Okay, so this is actually a throwback to January 1930. This is the discovery plate for Pluto.
wow.
shouldn't there be two?
What's that?
Shouldn't there be two?
There should be.
Yeah.
Clyde Tombaugh at Lowell Observatory in 1930 was looking at two plates taken on different nights with what they call a blink comparator. So it would flash back and forth between the two plates, and then that makes something that moves a little bit obvious to the observer's eye. And so he found this dot, and they later figured out that was Pluto.
And that was, I think, a 13-inch telescope, a 13-inch
Yeah.
imager.
I was just going to ask what size, but
So, and it's out there almost in the Kuiper Belt, isn't it?
I think that defines the start of the Kuiper Belt.
Well, there's
It's
other.
got an elliptical orbit that's tilted.
Yeah, it's not in the plane of the orbit. It's not along the ecliptic.
But there's
I don't
other-
know if you wanted to discuss this, but why in the first place did they think that there was a planet out there? There was some kind of perturbation in the
Yes.
orbit.
Yes.
Well, it turns out there wasn't, but Percival Lowell saw that, they discovered Neptune using perturbations with Uranus, and he thought there were perturbations in the orbit of Neptune. And so he went out and did a bunch of calculations. Turns out they were in error like crazy, but he just happened to have one area of the sky that he told Clyde Tombaugh to look at, and they found Pluto there. So it was accidental, really.
Mhm.
Okay, interesting.
You suppose Planet 9, if it's 6 times bigger than Earth, is a rocky or is it a gas?
Both.
Yeah, I don't know.
Might have an atmosphere.
Could be either.
Okay.
From what you're telling me here, it sounds like it's going to be a planet zero.
Yeah.
Planet Zero, what's that?
It doesn't exist.
Oh, yeah, that's probably true.
Yeah.
And this
So
is
far-
another case of there's mathematical reasons to look for it, but it may not be there. Yes.
Right.
Wow.
So this is the moon right now. We're traveling between a waning gibbous. This is what it looks like tonight.
Yeah,
That's
pretty much
seven-
last night too, Jerry.
It's
We-
what?
Pretty much last night too. So
Yeah, it's not gonna
we
be
got
a-
it in binoculars in my sky window. It was really pretty.
And then
You
during
must
the
not
week,
have the
this is
same,
what it will look
diagram.
like a month,
Next
a week
next-
from now, Monday
Yeah,
or next
next
week.
Monday. Mhm,
So this is the time to look at all the stuff that's in here.
mhm.
And there's a couple of people that are very prolific in taking excellent lunar photos. One of them is a French guy named Robert Cazellac. And whoops. And he has some nice pictures. Unfortunately, the picture doesn't blow up real well, but this crater right here is called Posidonius near Mars Serenatus, whatever. So, and this is his photograph of it
Jeez.
on this side. This is his photograph of Posidonius, and this is the Lunar Reconnaissance Orbiter photograph taken
Wow.
directly above. And if you look real close at the two pictures, I think that he took this with a Celestron 14-inch edge
Mhm,
from France, and I think that there's actually more detail in this one.
mhm,
So, but they're similar in shadow.
Jerry, was this the images from last Tuesday night workshop?
I don't understand the question.
Well, last Tuesday night, there was somebody that I don't remember who it was that was talking about this one man that was doing fabulous lunar imaging.
Oh, I don't recall. There's a number of people that do this fantastic imaging, and they're Facebook friends of mine, and they post these things on Facebook.
Okay.
This is one of the two. Uwe Milling is one that his first name is spelled Uwe, and this one is Robert Kazalak. There's also what is it? Go, I forget.
Christopher Go.
Christopher Go, yeah. And there's one or two other ones that just do fantastic work. This is beating LRO is pretty nice. So you can see this fault line right through there.
Oh yeah.
It's only barely visible over here. So
boy, that's amazing.
Yeah.
That's amazing.
And there's if you tune into our Tuesday night workshop, we've been talking about new plugins or softwares that is AI based, and they are head and shoulders above anything we've had before about digging out clear images, getting rid of noise and distortions. It's a phenomenal age we live in.
Well, one of the things I've learned about your craters, Mr. President, is that there's usually a peak in the middle, which is the after effect, but that's on that picture. Can you go back to it?
That's Ron, that's only in really high energy impacts.
Yeah.
Okay, but this is that round thing in the middle of this is a secondary collision, isn't it?
Yeah, what happened here, the this crater here is quite old, and it filled in with lava and had a flat surface. And then these guys and this guy and these guys hit later.
Seems to me the right picture shows the moon turned a little bit more toward us than the one on the left.
Yeah, the lunar reconnaissance orbit was directly above the crater when it took the picture. This is how we see it from Earth with it foreshortened.
Wow.
Because it's partway around the edge of the moon.
Well, that's just a fabulous image.
It is. This is another image of Ptolemy, and this one is the Lunokhod 2 path that rover, that Soviet rover took on the moon.
Really? Are they still getting stuff back from it?
No, this is all historical.
Well, in some sense they are, because it has retro reflectors on it and they can bounce a laser off of it. But
that's right.
Okay.
If you notice the word "end" in that last picture.
You what?
The word "end," E-N-D.
Yeah, here's the start over here of the path. Then it went around here and up here and then end.
Did it have a untoward event? Did something happen to it?
I don't recall.
I think it just failed from thermal stress.
Oh,
the moon has no atmosphere to protect it from proton bombardment from the sun, and solid state electronics is very susceptible to radiation damage.
Yep.
Wow. Well, let's go to that next picture, and there's one word we got to think about that's kind of in the picture. Spelled backwards, it's park.
Park?
Yeah, park. Yeah. Oh crap.
Well, this is someone added this to the picture, but this is the first picture of Odysseus after it landed.
Well, it's not an actual image.
Yeah, it is.
It's maybe an artist.
I don't think so.
This is an artist's rendition.
Okay, wait.
Has to be.
On the way down, the Odysseus ejected a CubeSat with a camera on that was designed to land next to where Odysseus was going to land and take pictures of Odysseus from this distance away.
Really?
So, but this image just doesn't look real.
I admit that, and you wouldn't see stars in the background if it were a real picture. So it may be a rendition.
Actually, this looks like a Gary Larson cartoon to me.
This is the actual picture taken by the Odysseus as it lays on the side.
No, this is as it was entering orbit around the moon.
The moon is pretty close here, I think.
Yeah.
Well, it's coming in for a landing.
Oh, it was? Okay.
Yeah.
I don't know.
Well, you can see two of its legs sticking down. I mean, down.
Yeah.
Sticking
Well, it was the legs weren't retracted.
Seems to be a fisheye.
That's what
Yeah.
it looks like to me.
It's probably out on a boom.
Yeah.
Wow.
It's a
Okay, I've
GoPro.
always- You know,
Yeah.
you've seen pictures of the LEMs they landed in Apollo, and you wonder, oh, how come that one stick, that one leg didn't hit that rock and tip the whole thing over? And now it finally happened.
Yeah. No, this if you look at the landing pattern on the internet, the vehicle was moving 2 miles per hour sideways, and they did not completely zero the sideways motion when it touched down.
Oh.
But
And
that-
that's
somebody's
something
looking
that
for a job,
Armstrong
huh?
had to train really hard for, was just to stop that lateral motion and
Right.
bring the LEM down, or those not just him, but the other lander.
I think the
Pilot.
reason those were successful was because they had a human pilot on board that was watching.
Ooh,
Jerry,
right.
do they ever allow for contingencies if a lander goes on its side, or they're not going to ever use it again, so they probably don't care. But I'm kind of curious.
I'll bet you from now on they start having things that will lift it back up. So this is the second thing to fall over on its side.
Really?
Yeah.
But they had to reprogram the thing and delay its landing, didn't they? Because they saw it coming.
No, what happened was Intuitive Systems had a laser rangefinder on the lander, and they were supposed to start taking altitude readings. But when they did a test, as they were coming in, they realized their system wasn't working. And it turns out that NASA had bought some payload space on this lander, and they had some lasers on it, and they were able to use the NASA lasers and send the data from those to their altimetry system to do the landing. And that might be partially why they still had some sideways motion.
Okay, but is this part of Artemis?
No.
Oh,
This
it's
is a
not.
private company, a separate company from SpaceX, even though SpaceX launched it into orbit.
And it just happened to land in the same landing area we're sending our astronauts in.
No, they targeted the South Pole, and this is at the South Pole.
See down on the lower right there, Ron, it says Intuitive Machines. I think that's the small company that
Yeah,
did
that's
this.
the company. Now this is an unusual flight path. Usually lunar probes orbit the Earth, then they zip off to the moon, then they orbit the moon, and then they land. This one went directly from the Earth to the moon and took 5 days to get there. So there were not orbits involved on the way.
And it's not coming back with rocks or anything like that.
No.
No.
Wow.
That may be why they didn't worry about any contingency to upright it again. But
Well, that's a lot of machinery you'd have to put on that takes up weight and space that you want to have for instrumentation.
Yeah.
So
yeah,
I doubt they'll bother with that on most systems. They'll just be much more careful.
They did use methane and oxygen as fuel, which is unusual
Really?
type of things.
yeah.
But did you just say it landed on the South Pole, this one here?
Yeah.
Here,
It's close to South Pole. It's at like 80 degrees south.
Yeah.
right.
But that's where we are going to land Artemis.
Yes, that's why they're going there.
Yeah. That's why. Yeah.
They're working together, sort of.
Yeah.
Yeah. It's
You think
US stuff. NASA involved.
Did we see frozen water in any craters with this sucker?
This one's not looking for that.
Yeah.
I thought I saw some glistening. Maybe it was an artist rendering again.
Stuff over there. No, this is a fisheye camera lens.
Well, it was other pictures that I saw, but maybe might have been Mars. Who knows? Fascinating. Pictures are going to be better than Apollo, I'll bet.
Yes.
All right, let's go into the heavens at night.
Okay. This is looking at what's called the winter alberio. And that's you remember that alberio is a double star, an optical double. They're not gravitationally related. And one's blue and one's gold, also known as the Boy Scout star or the UCLA star or whatever,
Or the Cub Scout star.
Cub Scout star. Now, Tim has pointed out a very nice way to find it. This is the constellation of Canis Major, the big dog, running along behind Orion. So it's a winter constellation. It's in the west now. But you go to these bottom two stars, the hind end of the dog. And by the way, this is the brightest star in the sky, Sirius. So it's easy to find this thing. You just go up here the same distance on that line, and you land on the
Alberio.
the double
Winter
star.
Alberio. Yeah, it's also known as Little H 3945.
Yep.
I
Okay.
learned that from Chuck.
John Herschel.
Yep.
Okay.
John Herschel. And
Well,
also
Chuck-
the mnemonic Chuck gave me was beginning and end of the Second World War.
And Chuck actually sent me a long time ago some data on the winter Alberio. I think it wasn't Alberio, but it was the winter Alberio. But where the two stars were and what the distances were, they just fall on each other. They're not very close.
Mm-hmm. Mm-hmm.
Winter Alberio. Is there a difference? Is there a summer Alberio?
Yep.
Oh yeah,
Yeah.
Cygnus.
That's Cygnus.
Hmm.
It's the eye in Cygnus, or the head of Cygnus the Swan.
yeah. I mean, Ron, it's the head of the swan in Cygnus in the summer. A very famous double that people always look at because of the colors, the contrasting colors of blue and iridescent blue, and then a gold color. And there's a few doubles in the sky like that, but this one, the H3945, people don't look at it very often, but it was suggested online that it's a shame because it's a really fabulous, it's a fabulous double.
It's a winner, yeah.
In the winter, it really is, and I show it off during the winter to a lot of people, and they're just amazed that no one shows it. It's kind of been ignored, really. Really nice one.
But you're saying it's a double. That means it's a binary, not
No.
No,
Binary is different.
Oh,
That's right.
It's in two constellations. It's in Canis.
No. It's just a chance alignment.
That's it.
Let me put it this way. The brighter one, they're both about magnitude 5. One's 5.9 and the other's 5. The brighter one, the 5.0, is 6,300 light years away, and the other one is 260 light years away.
Oh, great, fabulous.
Yeah.
So one of them is super bright but very far away.
Yeah.
Yeah. And Jerry, if you go back to the other end, your little sky chart, the previous that one. Yeah, so those two stars there, I think, are Aludra and Wiesen. And like Tim said, they point directly to H 3945. But if you take your little hand and you go directly down from that target, that right there, that's 2362. That's really
okay.
beautiful. That's really beautiful. So I also use those two dog stars to point to that thing, and I show that to the public a lot in the winter.
And if
You
you
could
go
also-
up above the word major, up there's another open cluster symbol.
Yep.
That's M41
Mm-hmm.
Pleiades.
The Pleiades. Oh, that's
It's also very pretty in binoculars.
The little Pleiades.
Now, if you also take those two stars and then you use that as like 1 and then 2 up to 3945, and you go out 4 times, you'll kind of land on M46.
Okay. Mm-hmm.
And that's an interesting cluster because there's a globular in there.
Now, where
You
is
mean a
No,
planetary?
planetary. Yeah.
Yeah.
where is M46 here?
If you
You're
follow
getting
the
close.
line-
Over upper left.
Yep.
Right. Right there.
This red thing?
Yeah. Yeah, there's a real spooky, Jerry. There's a real spooky planetary in the middle of that.
Oh yeah, that's
I think it's an open cluster. It's not a glob.
okay.
It's an open cluster with a planetary in it.
Yeah. And
There's
if
at
you
least
use a
superimposed
filter
on it.
if you use a filter on that in a fairly large scope, it just is spectacular. It's real pretty.
Would it be safe to say, gentlemen, we're going to have a pretty dark sky in 2 weeks from when we do Saturday night star party? The moon will be swiftling over, won't it? And we'd be able to see this better.
Provided the clouds stay away.
Yeah.
Yeah, we'll be all right. We'll be all
Yeah,
right.
it should be a dark night.
Okay.
Now, when I look at, now this is an Auriga. When I look at this in the sky,
Mhm.
even though it's across the border, my eye makes a asterism out of this set.
Right.
Yes,
And
yes.
this would look like the floor, and this looks like the peak of a roof to my eye.
Right. Yeah,
And
I see a
these things-
house.
These things stick up here, and it's a series of open clusters, very nice open clusters.
Yes.
And Astronomy Magazine points out M38 in this case at this time because it's a very nice open cluster. And the reason we're looking at stars and open clusters this week is because the moon is still very close to full, waning gibbous, and it's hard to see faint fuzzies and galaxies. So stars and clusters are the easiest thing.
That's it.
Yeah.
That's
I
it.
always see Auriga as a big pentagon.
Or a bent horseshoe.
Yeah,
Yeah.
oh yeah, yeah.
So 1, 2, 3, 4, 5. Yeah, that's how I see it, the Pentagon.
Yeah, and then I'm with Jerry. I see that as well. And it's, to me, it's
Right.
that shape.
See, that star down below belongs to two constellations, Taurus and Auriga.
Uh-huh.
Okay, it's
Well-
called El Noth. It's called El Noth, which means the butting. So it's the horn.
Yeah.
Oh,
But
so
but
there-
now technically each star belongs to only one constellation. That used to be right on the border, and you could say it belonged to either one. And the same thing with Alpharats
Mhm.
in Andromeda. But
Mhm.
now they officially belong to one or the other.
Okay.
oh, really?
Yeah.
So well, let's see. Shiata is the one at the top, and then Alpharats is on the way to Mirak.
Yeah.
Yeah.
So I guess the takeaway here is don't confuse official naming with reality.
Yeah.
Yeah, and for folks with binoculars and steady hands, there is a beautiful little smile face near M38, and it makes M38 look like a dimple. It's pretty. I got it Saturday night for us. It's really neat.
What's the little hook on the right? Can you go back? Halfway between those two big stars on the right, there's a little hook. What is that?
Those are the kids, you mean, up there?
The
Yeah.
little triangle of stars.
Yeah, they're
Yeah,
called
right.
the kids.
The kids. Okay.
Yeah, because
Really?
Capella's the goat star.
Okay, got it. All right.
That's interesting. I never knew that.
Capella's on the top there.
Yeah.
But there's two constellations here overlapping, you said. Taurus as
No,
well.
just this one star is on the borderline.
Yeah.
Oh, okay. Otherwise, those four big stars at the top are not part of another constellation, or is this
They're part of Auriga.
Yeah,
Auriga.
this is the borderline. Well, this is the borderline with Auriga.
Oh, okay, got it.
So
What's it
and this
pictured
is-
as?
what's that?
What's Auriga pictured as?
The
A goat.
chariot driver holding some goats.
Yeah.
Only being pulled by goats?
Can't you see it?
Yeah.
I'd imagine Charlton Heston and Ben-Hur being pulled by goats around the corner in that race scene.
Chuck, you're great, man. That's really good.
So
obvious.
This is a puzzling picture. It's M38 taken by an amateur in Weston, Florida, taken by a 102 millimeter Takahashi f6 refractor. Now, if this is a refractor, where do they get these diffraction spikes that usually come with a,
He stuck an appetizing mask on it.
he's got something on there.
Wish I understood what you were talking about.
See the spikes on the stars, Ron?
Yeah. You
Well,
said-
with refractors don't show those, but the spikes usually come from a reflector that has a spider in it, the thing that holds the diagonal mirror.
Secondary mirror. Now, there was a guy I met at CalStar one year, and he puts fishing line monofilament taped across in a cross pattern in front of his objective on his refractor because he likes the diffraction pattern they give.
Yeah.
And I bet that's what happened here.
That's what I suspect. But you know, anything will do it, as Chuck pointed out, a mask.
Yeah.
I took a picture of the Pleiades once where I left the Botanov mask on,
Oh, I've
Yeah.
done that a couple times. Yeah.
and I really like that. It looks
Okay.
pretty cool.
Not me. I hate myself when I do that.
Whoa, this is unreal.
Okay.
You're-
now,
You're
this
telling
is
me you're telling me these spikes come with a concave mirror lens?
No.
It doesn't have to do with the mirror. It has to do with the secondary obstruction that gets in the light path.
Oh, well, you okay. I'll take your word for it.
okay. Now this
Whenever you have an edge, you get interference patterns.
But sometimes you get 6 spikes.
It depends.
the-
It depends on
how
what
many
the
spiders
obstruction
there are.
is.
the
On
geometry
James
of the
Webb,
aperture will do it too.
Yeah.
And a dirty lens will do it also.
What lens? Oh, a dirty lens. Yes.
Or a telephone wire.
Yes.
But this is the Pons Brooks we're looking at, right?
This is Comet Pons Brooks. This was taken, that's near Vega. This was taken in, I think it's April of this year. Oh,
Wow.
December 4th, 2023.
That's unbelievable.
So this is the one that under some conditions looks like the Millennium Falcon. Yeah.
Oh,
Now this is Andromeda, and this is where 12 Pons Brooks is located on yesterday, the 25th of this month. And so it's way in the west. It's going to be a challenge to see it.
And that's Alpha Rats there down and left, the big bright star, Alpha Andromedae.
Mhm.
oh.
Yeah, right there.
And so you
Okay.
can see it belongs to Andromeda, even though the lines for the Great Square of Pegasus included.
Gotcha. That's what I was wondering, Chuck.
And
I
I
always
see
get
for
G-Act and
Pegasus,
Alpha
I do see the square.
But I'd love to issue a challenge to you guys to bring us a photo you've taken of this sucker.
Oh, okay.
It's tough because it's so low in the west right
Yeah.
now.
Yeah, it's in the glow.
Well,
Okay.
not from the star party, you ain't going to see it, but maybe from the top of the hill, Camino Cielo, you will.
Yeah. So this is what the comet is doing right now. It is coming in. This is our ecliptic down here. This is October of last year, and this was 268 million miles. It's coming across our ecliptic. This is on April 8, 2024. And the reason that that date was selected is because that's the date of the total eclipse of the sun.
Yep.
And this is, make that a little bigger. This is Pons Brooks for this year. Starts up here, goes around here, and the music comes out here. This is where it will be in the
Right.
eclipse.
And the hip bone's connected to the thigh bone.
No, that's a different song.
Oh, you're right.
You press the first valve down. The music goes round and round. Oh,
All right.
it comes out here. So this is Andromeda up here. There's Pegasus, and there's that little kinky thing up there. And this is on 2/25. That's yesterday, and that's where Pons Brooks is then. It's moving pretty good now. So
Rarely do we hear this from anybody that it's coming in or it's going out. You'd think they'd have a conjunction term for that sort of thing.
Well,
Now,
pre-perihelion and post-perihelion.
now this is, you see, here's that kinky part of Andromeda again. Pons Brooks is down in this area. I couldn't get the highlighter to put two highlights on the same field. So we have to go back and forth. But the Pons Brooks was down here. This is the blue snowball. It's
Nice.
it's just off of Pons Brooks. So if you find one, and you can find the other. And then this is a Hubble view of the blue snowball, which is a sun type star that has shed its outer coating.
So it's a planetary.
It's a planetary nebula. And
Wow.
it's apparently pointed right at us. So it's not a sphere, it's believed to be a tube shaped pointed at us.
And you know, the star hop for this isn't too bad. It's like when you go to the image before, there's 2 stars in that in that little hook you're talking about.
Yeah, right here.
Yeah, but there's 2 stars that are actually pretty visible in the sky, and you kind of go it's not halfway, but it's a little bit further than halfway to find the blue snowball.
So
I'd have to in the night
here
again.
and here.
No, I think it's in the other image you had of the hook, where you had the blue snowball in it.
This is the blue snowball.
Oh, okay. Then the two stars, one to the right and left, just on a line with it almost.
Oh, this one.
That
and
one
this
there,
one.
that one there,
Yeah,
right?
okay.
Those are pretty visible in the night
Yeah.
sky, and they
So-
run parallel with. I think it's with to the edge of Pegasus.
Andromeda.
I think.
Yeah, this is Andromeda, and this is Pegasus down here.
Yeah, and it kind of runs parallel with that. You can really see these 2
Yeah.
stars, and you just go a third of the way, and that's the way I find that blue snowball.
Mm-hmm. Yeah, this is an easy star hop. It's an easy object to find when you've got a crowd of Cub Scouts waiting to look through your telescope. Now here we're looking at what will be in the evening sky in the summer. This is Scorpius. This is the tail of Scorpius.
Oh yeah.
And these are what I call the stinger stars.
Right.
There's some nice ones in there.
Oh, Tom shows me one every year. It's the
Yeah, less south than Shaula, the stingers.
Yeah, now we're looking at M6 and M7,
Mhm.
and this is one of them, and
S7.
this is the other one.
6.
Yeah. And the False Comet is down here. I believe this is it, isn't it?
Yes.
So you have this is way south for us here. It's good to be on top of a mountaintop. We've seen it from the gun club up at Camino Cielo. And
We're backyard here.
and about 3,000 feet for the gun club, or 2,900 feet for Tom's backyard.
We're only 600 feet up.
Okay, good.
We're only looking at the tail though, right?
Yeah.
Yeah.
But this is M6. It looks
Looks
like
like
a bunch of jewels with a large red giant over here. Very pretty.
that Ptolemy or the butterfly?
It's the
That's
butterfly.
The
You
butterfly,
can kind of
okay.
see the butterfly in it.
Okay.
Yeah, to me, it looks like the wings are here, and these are antennas sticking out.
Yeah.
Oh, okay.
Yeah, beautiful summertime thing for the public.
This is the prettiest picture I found this week. This is the other one.
Ptolemy's cluster.
Yeah,
Ptolemy.
M7, the Ptolemy. Yeah. And these are all pretty much hot stars. Remember, the color of the star tells the temperature of the star. These are all very hot stuff, blue giants. This one is kind of running out of fuel, I guess. So it's kind of fading. But it's
When we're out in the summer and Tom's around, he won't let me go without looking at him.
yeah.
It's really pretty.
It's also, it's naked eye from the Bacara, you know.
Oh yeah.
But we're out of Scorpius now with these stars?
No, we're still in
no.
Scorpius.
We're still in the tail. Okay.
Yeah.
Really, really pretty, Ron. It's a
Yeah.
pretty cluster of stuff.
And Jerry, if you have an 8-inch telescope on M7, you'll get a globular in the background.
Oh,
It's kind of cool. It's tough. It's tough though.
Well, scorpions also have pinchers in real life. Are they depicted by stars as well? Pinchers?
Mhm.
The 2 stars that are now in Libra the scales
Yep.
are called
Okay.
Zubin el Janubi and Zubin es Shamali, which mean northern and southern claws of the scorpion.
Got it.
Traditionally, they were the claws, but the Romans swiped them from the scorpion and they made Libra the scales. So
Okay, got it.
this is what we're looking at. This is the tail of the scorpion, and I cropped it up here to get a good look down here. So
Mhm.
the claws are up here. about of the frame.
Yeah.
Okay.
You can see that globular, Jerry, next to M7 up there.
Yeah.
See that
Little
glob
symbol
right there.
Yeah.
Mhm.
Oh,
It's tough pick off though. That's
These
really,
circles are open clusters. No,
Wow.
these are planetaries.
yeah,
These ones with the cross in it are globular clusters.
they're globs. Yeah. Mhm.
Yeah.
You going to be able to show us the new atlas of the Milky Way before we go, Mr. President?
Yes, this is a constellation of Leo. And right here, this is Leo's heads out of the picture. This is the tail. So down here is this triplet of galaxies, which is called the Leo triplet. And it's I call it the gateway to the Virgo cluster over here.
Got it.
And this is the picture of the Leo triplet,
Yeah.
M65, M66, and the
Hamburger.
cheeseburger,
Oh,
hamburger.
hot dog.
Chuck likes hot dog. My old club liked hamburger.
Okay. Now, this is
3628, Chuck?
Oh, I don't remember the NGC number.
I always forget it.
I think it's 36.
3628.
Oh, right. Nailed it.
Yes.
Thank you. 3628.
Now, this is from an article by Scientific American in the current issue, which I've been meaning to re-up on my.
We're going to have to do this as a whole topic at some future show.
It is, and it's a very long article, but they only have this one really good picture set up there. They're showing all the major features of our type of galaxy. They washed out the center, which is now we are a barred spiral. So our galaxy has all these things that indicate the history of how we came together. We have a sphere around us of globular clusters. These star symbols are globular clusters. These globular clusters are not in the plane of the galaxy. They are a sphere around our galaxy, orbiting the center of our galaxy. And then we have these streamers, this like arms that have become detached or never were attached. But these are things from globular clusters that have. A globular cluster is a competition between the gravitational pull of the massive stars holding it together and the tidal forces of being so near a massive object as the Milky Way. It tends to pull things apart. And these streamers are stars from globular clusters that have been pulled apart by tidal forces into streams. And they're also dwarf galaxies that are near us that have been pulled apart in the past. Other dwarf galaxies that have not been pulled apart but are still dwarf galaxies are indicated by these cubes. There's one there and there's one there for the Magellanic Clouds, the big and the little Magellanic Cloud.
So we can't call those streaks galaxy comets. We go a little too slow to have a comet go in and out of the galaxy.
Hey, Ron,
Yeah. Right?
it's the February issue Jerry's referring to. It's really good.
Yeah,
Scientific American.
yeah, that's where I got this was from, but online.
Mhm.
Yeah.
I thought there were only two magazines, Astronomy and Sky and Telescope, but there's
Oh no, there's a zillion.
There's lots of them.
There's Discovery, there's Nature, there's Astronomy and Sky and Telescope, and Scientific American, of course.
BBC
Mad Magazine.
at night.
Mad Magazine.
Well, let's put it on the calendar and talk about it in the future as we get ready to switch over to a new year, guys. Got to bring things to an end. President and I are going to be on screen with Tom Totten talking to Berman tomorrow morning in a test run. I wish it was done in Fleischmann to see if we could hear the guy on the screen.
That wasn't clear to me if they want me there in Fleischmann or they want us to do it online.
Well, between us, we'll get in touch with Mr. Totten since Mr. Winkowski is not in today. He comes in tomorrow, and we'll see how that works on Friday night as we get ready for our new season. Guys, thank you very much. I learned a lot. Let's talk again. Start the new fourth year next.
Good show, Jerry.
Okay, thanks.
SBAU Astro Hour over and out. Thank you.